So today we are going to derive Lorentz transformation using the Galilean transformation in just 3 steps. Let's understand what the 3 steps are. The step 1 is to understand the goal. First we need to know that what we are deriving. Step 2 is understand what's already given. That means we need to know the Galilean transformation, what they are and what it's telling. And then step 3 is calculating the speed of light in both frames. Special relativity postulates tell us that the speed of light is always constant, and that is the fact that we use to calculate the Lorentz factor, which tells us how much the position and time coordinates are offset when we are moving at a relativistic speed. So starting with step 1, let's understand the 2 frames of reference that we have under consideration. So frame S is stationary and frame S dash is moving towards the positive x-axis with speed v. Now v is the relativistic speed. In Galilean transformation, we just say that x minus vt is equals to x dash. X dash is the coordinate in the S dash frame of reference. This relationship comes to us intuitively, and it relates x with x dash. These equations, however, don't work when we are moving at a relativistic speed. So for that, we assume that these are offset by some factor k. So we just multiply k to the entire right hand side. Just like we found the value of x dash in terms of x, we can also find the value of x in terms of x dash. Now we did not just use algebra to find the value of x in terms of x dash, we inverse the value of v. We changed the sign of v. Because from point of view of S dash, frame S is moving behind, while from point of view of frame S dash is moving forward. Now moving on to step 2. Understanding what's already given to us. Not all information is handed to us directly. Sometimes we need to use our brains. In Lorentz equation, we had the relationship between x dash and x. We need to find the relationship between t dash and t now. So what we do is we take the equation for x and there we input the equation for x dash and just solve it and algebraically find the value of t dash. So now we have an equation for t dash, we have an equation for x dash. It's time to move on to step 3. Step 3 is calculating the speed of light in both frames of reference. Speed of light, just like we calculate speed generally, we will just divide distance by time. So x upon t or x dash upon t is the speed of light. We know the value of x dash, we know the value of t dash, we will just input that and solve it algebraically to find the value of k. And this is how we get k as 1 upon square root of 1 minus v square by c square. If you face trouble with the algebra, you can just pause the video and take screenshots of all the steps and match it with yours. To find the final equations, you just need to input the value of k and simplify. Now before this, I uploaded a video on how to solve for Lorentz equation without using Galilean transformation, and as you can see, we get the same result each time, whether we use the Galilean transformation or not.